number 2 for building polynomials. We'll start with number 3 again. We're going to write an equation in factor form. So in order to write factor form, you have to know where your roots are. The first root's at -3, so our factor is going to be x plus 3. It cuts right through, so it has a multiplicity of 1. You don't have to write the 1, I'm going to. Our next root is at 0, which means you just had an x out in front. Now this root bounces off the axis, so it has a multiplicity of 2. And the last root is at 4. So we'll write a factor of x minus 4. It also bounces off the axis and has a multiplicity of 2. Now notice that we have to decide positive or negative. My arrows, if I connect them, they're in opposite direction, have a negative trend, which means I need to put a negative in front of the equation. The degree here, when I add up the multiplicities, 2 plus 1 plus 2 is 5, which we call quintic. And the end behavior, on the left, the arrow is going up, which means it's going to infinity, and on the right, the arrow is going down to negative infinity. That should be pretty straightforward and easy at this point. Classifying degree and end behavior. Number 4, we're going to write standard form of this polynomial. I have a root at -1, which means the factor I write in order to get me to standard form has a positive 1. And the fraction here, I bring the 3 up in front of the x and take the opposite of the numerator. Now all I have to do is distribute and you get standard form. X times 3x is 3x squared minus 2x. And I have plus 3x minus 2. And I combine my terms. 3x squared stays the same. Negative 2x plus 3x is plus 1x minus 2. The degree is 2. It's called quadratic, so that means there's one term. And the end behavior, well, the degree is even, so they both go in the same direction. This means it's a parabola that opens up because the leading term is positive, so both arrows go to infinity. If you're not sure about the end behavior, graph it, right? Our answer was 3x squared plus x minus 2. You can see both arrows are going to go up when you make that. All right, the next one, number 6. I'm writing standard form. I'm giving you function notation, so you remember that this tells me every number in the parentheses is an x for function notation. So I have a root at 0, -4, 6, -2. I'm going to start by writing the factored form. The factor for 0 is just x. The factor for -4 is x plus 4, x minus 6, and x plus 2. Now there's going to be a fair amount of multiplying here. I like to start on the right. Take your time and be really careful. All right, I'm going to start on the right here. The first 2 are just going to come down and stay as they are. Okay? So I'm going to have x times x, which is x squared. Now I'm going to have plus 2x minus 6x. So it's going to be minus 4x minus 12. Now I skipped a step. I did a little bit of that work in my head, but I have positive 2x and then minus 6x, which is negative 4x. I wanted to do that so that I could save a little bit of room. Now I'm going to multiply the next 2 together. These guys. The x is still going to stay put. And I'm still going to get, let's see, so I'm going to have a lot of multiplying here. When I multiply this, start with the x. X times x squared is x cubed. Minus 4x squared. Minus 12x. Then I move on to the 4. Plus 4x squared. Minus 16x. And minus 48. That's a lot there. So why don't we, I'm going to actually just distribute the x, and then we'll combine like terms. So when I distribute the x, I'll have x to the 4th. Minus 4x cubed. Minus 12x squared. Plus 4x cubed. Minus 16x squared. And then minus 48x. Okay, now we combine like terms to get our standard form. X to the fourth is the only x to the fourth, so that's the first term. X cubed, I have negative 4, positive 4. Those actually cancel off, so there's no x cubes in my answer. Negative 12x squared and negative 16 would be negative 28x squared. And then minus 48x. This is a good one to type into Desmos, see if you get the right roots. So I'm going to do that for us. I have, let's see, x to the fourth minus 28x squared minus 48x. Now, the graph is kind of funky here, but we wanted to make sure we had a root. Oops, did I mess that up? I forgot the x. There we go. I want to make sure I have all the roots, right? It said I wanted a root at negative 4, which I have, at negative 2, 0, and 6. So I have all the x-intercepts, so I'm pretty sure that I did my work right. All right, last one, do number 7. We're just writing factored form. So just like the last one, we're in function notation. So I'm going to rewrite this as x equals. All right, when I write my factored form from a fraction, the 2 comes up in front of the x, so it'll be 2x, and then opposite of the numerator. The second fraction is the same thing. I'll have a 2x there, and the opposite of the numerator. The opposite of 7, which is x minus 7, and the opposite of 11, x plus 11. The degree here, I count the multiplicities, which will be 1, 2, 3, degree of 4. It's called quartic, which means I have 3 terms. I could graph it to find the end behavior, or I could know that a quartic graph would have 3 terms. The arrows would both be going up because the leading term is positive towards infinity. All right, that's your building polynomials practice number 2. Ask your teacher for more help if you need it. Otherwise, go ahead and move on to the test 3.